Welcome to Fire Engineering's Training Minutes. I'm David Rhodes, and we're here at the Guardian Center's concrete collapse structure, and I'm joined today by Jamie Brads with Virginia Beach Task Force and also instructor here at the Guardian Center. Jamie, how are you doing?
Very well, sir. How are you?
Good. So we've got an access hole, and we've already seen the patient with a search cam. And now tell us a little bit about how we're going to get to the patient.
Well, first things first, we would have to, once we looked in the hole, we would determine where the victim was located, whether or not we had to do a clean breach or a dirty breach.
All right. When we saw her, we were able to communicate very well, and she was mobile, and we were able to get her back away from this area.
Okay, so then our best choice will be a dirty breach because we can do that much faster. Clean breaches involve bevel cuts and actually lifting a piece of concrete out as a whole. A dirty breach is making big rocks into very small ones.
And this slab is thick enough where we wouldn't be able to clean breach it with one cut. So
it'd be very close, and we were a little afraid that we wouldn't be able to bevel it to get all the way through, so we might have to do what's called a step cut, which makes the hole much larger so that we can get in to get down to the depth that we need.
So in looking at time, how long would it take us to clean breach a slab of this size?
This slab, again, being as thin as it is, we probably could do this in 35 to 40 minutes. Typically, a slab that is 8 inches to 10 inches thick takes us anywhere from 40 minutes to an hour, depending on how much steel's involved.
So our choice for this is going to be a dirty breach. So tell us a little bit about the tools we need to accomplish that.
Well, once we have our inspection hole bored and we've made the determination we're going to go with a dirty breach, what we're going to do is we're going to take a rotary saw for cutting concrete, and we're going to make a relief cut across the inspection hole. So just a plunge, and an X across the inspection hole. What that does is relieves the concrete somewhat. Then we're going to take a jackhammer of some sort. We happen to have a Stanley hydraulic, and it's a BR87 unit, and we're going to just start working from the inspection hole out throughout our X that we've relieved the concrete.
All right. Now, a rotary saw is equipped with a special blade. This is not just your typical hardware store blade, so tell us a little bit about the diamond blade here.
Yes, sir. Rescue saws turn a very high RPM, and this is a wet-dry diamond wheel. We typically use them in a wet configuration because it lasts us longer, and typically the concrete that we're cutting has some sort of steel in it. This will cut the steel as long as it's embedded in the concrete. If it's not embedded, it'll cut steel outside of concrete, but it just wears the wheel down a lot faster. So the wet configuration within the concrete is what keeps the wheel cutting. And what happens is as it cuts through the concrete, the abrasiveness of the concrete wears away parts of this segment here, exposing diamonds. The diamonds are what's actually cutting the concrete and the steel.
So it kind of regenerates itself
kind
as
of
it
sort
goes.
of to a certain point. Once you can't feel differentiation between the actual segment and the wheel, when there's no segment difference, your wheel's not going to cut very good. So your kerf's not very wide. This is creating the kerf so the wheel doesn't bind.
One mistake I've seen a lot of folks made is they put the blade on the wrong way. Can you tell us a little bit about how to determine which way it goes on?
It really does depend on the wheel. This is a universal wheel. This one, the segment doesn't matter which way you go with this one. Some of the USAR blades that are out there that are the high speed, they cut concrete very, very fast. They are directional, and basically they will show you an arrow with a circle in which way it should go on to the machine, the cutoff machine.
All right, well, we're going to make an X relief cut here just by coming across our hole this way and this way.
Yes, sir.
And then we're going to get to chipping. So you ready to go to work?
Yes, sir.
All right, let's do it. All right, we're getting ready to make our relief cut. Jamie, we were thinking a little bit about how we would work in pairs to get this accomplished. So tell us a little bit about that.
Yes, sir. Again, you see we're on a pile of concrete and debris everywhere. We try to work in pairs because when you're running the saw, it's a tremendous amount of noise, a lot of vibration, and sometimes you lose track of where you're at. So you'll have someone spotting you safety typically. Sometimes, in your case, this time, again, I like to use water on these wheels. It helps with the process as we're cutting through the concrete. They do have hookups, but this one is actually broken from hitting a piece of concrete.
So we're actually in a real world situation. We've got a broken hookup, so we got to keep moving.
Yes, sir. We're still being able to move because you're going to spray a little bit of water, just enough to continue to make chocolate milk on my wheel. So as long as we're making good slurry or that chocolate milk, we're still going to be cutting concrete. So we don't have to actually have it coming through the machine. We can spray it out on externally.
One thing from a command perspective, a lot of times when you talk about rotating crews, we don't mean taking this crew off of this station and moving them out, because there's so much situational awareness that is lost on what's going on. So we're talking about rotating within a small group and watching out for each other. So if we get tired running the hammer or running the saw, we'll just pass it off to the next guy and rotate positions that way.
Yes, sir. Very, very typical.
All right, let's get to cutting.
Okay.
All right, so we've got our relief cut made. Now we're ready to move to the next phase, and that's when we're going to bring in our chipping device, our jackhammer here. So tell us about it.
Yes, sir. Again, this is a Stanley hydraulic jackhammer, pretty typical for USAR application. Various amount of tools that we can run off the hydraulic power unit. This happens to be one of their larger breakers. It's a BR87. We happen to have a small chisel in it instead of a very wide chisel. Or a moil point or bull point would work pretty well here for punching through. What we're trying to do is punch through, but we're kind of going to do a little chipping as we go. When we made our relief cut, basically all we did was take the 14-inch wheel and sink it full depth, and then maybe move a little bit, but not very much. And that relieves the concrete a full 5 inches in depth at the center and then moving out. So we have a fracture line already started for us.
All right, before we start, let's set it up and show exactly where you're going to start from and what direction you're going to move to.
Basically, I'm going to position the tool in within a couple of inches of the inspection hole, because I've already got a huge fracture point there. My first initial couple of hits, I'm going to be chunking off pieces of concrete. What I'll probably have you do, or someone else do, is take a crowbar, an E-tool, an old entrenching tool, and dig out the chunks. As the chunks come out, it just frees up my space so I can continue to work through it.
All right, so we're going to start close and we're just going to work our way out.
Yes,
bigger.
sir. Yes, sir.
All right, let's get to it.
As you see, we already got a pretty good hole started.
All right, we took a little break here to take a look at our hole. We've got a large enough hole now that where we can get our rescuer down in there, get some more supplies to our victim, and reassure the victim and protect them even more. What else we got left?
Really, we could squeeze a small rescuer beside that, but to afford the rescue to get a victim out, we need to remove the steel. So with a few more chips from the hammer, we're going to make this hole a little bit larger. Then we're going to take our cut-off saw and go ahead and cut the rebar that's in the way.
All right, let's get to work. You want any water, or you just dry cut?
Dry cut.
Do what? All right, so we've accessed our patient. We've got a rescuer down to provide additional care and supplies. We've had the crews looking out overhead for us and around. We've been working together to accomplish getting a bigger hole. Looks like, what do you say, Jamie? We've got probably a good 24 by 24
Oh, the two of us can go through it together.
a hole, so we can get down there. Now we're ready to start setting up our equipment to get the patient out. Thank you for joining us today on Fire Engineering's Training Minutes. I'm David Rhodes, your host, and thank you again to our sponsor, TechGen.